So this is going to be the last theorem so that we can put polynomial functions a little bit to rest. So this is what we call the rational zero theorem. So basically what this says is that the rational zero theorem states that if a polynomial, so we've seen this polynomial many different times, has integer coefficients, okay, so just a number that are positive and negative whole numbers, then every rational zero of f of x has the form p over q, where p is a factor of the constant term a zero, okay, and q is a factor of the leading coefficient a sub n. So what exactly does that mean? So p here is a factor of the constant term a zero. So that's this last term right here. So what does it mean to be a factor? So a factor, remember that it's just all the multiplication things that can multiply to that particular number. So we're going to be able to do all the factorization of a0. Q, though, this Q is going to be all the factors of a sub n. A sub n is right in the front. So basically, if I know nothing about this polynomial, okay, I know nothing about it, I don't know any zeros, because just what we've been doing in the previous problems has been, well, I know at least one zero. If I don't know any zero, then I can find a potential zero by just taking all of the factors of a0, which we're going to call p, and then divide them by all of the factors of an, which is going to be q. Okay. Now, this is not going to guarantee you that it's going to be all of the all of the zeros, but you can find one, and then based on one, you can find the rest. Okay. So there's hopefully will be one that will exist. So let me just start off by giving you an example of what that kind of looks like. So list all possible rational zeros of f of x is equal to 2x to the fourth minus 5x cubed plus x squared minus 4. Okay, so we want to find, we know nothing about this polynomial function, and we want to try to figure out all the possible rational zeros. So which one is a possibility? Okay, so the first thing that we're going to do is we're going to find out our p. Okay, p is going to be in relation to my constant term -4. Okay, so that's -4. So you got to think about what numbers multiply to get to 4. Well, we know that 1 and 4 are factors, and we also know that 2 and 2 are also factors. Okay, so now because there's a -4, notice that this can be plus or minus. So basically, all of these are all factors of -1. 1 is a factor because it can be multiplied by 4 to get 4. 2 is a factor because it can be multiplied by itself to get 4. 4 is a factor because you can multiply by 1 to get a 4. So these are all the possible factors of my constant term. And now what we're going to look at is look at my leading coefficient 2. That's going to be with q. So we're going to look at 2. 1 clearly is a factor, and so is 2. And that's basically it. And we're putting plus or minus because a negative and a negative can also give me a positive 2. All right, so now what we're going to do, we need to figure out what p over q is. And what we're going to do is we're going to list all of them. So plus or minus 1, plus or minus 2, plus or minus 4, divided by plus or minus 1 and plus or minus 2. Okay, so now what we're going to do is we're going to try to divide. So the first thing that we can divide is this 1 and this 1. It's going to give me plus or minus 1. We can divide this 1 and this 2. That's going to give me plus or minus 1/2. Then you got this 2 and this 1. It's going to give me plus or minus 2. If I divide this 2 with this 2, you're going to get plus or minus 1, which is already there. Then we're going to look at the 4. 4 divided by plus or minus 1, going to give me plus or minus 4. And then 4 and 2 is going to give me another 2, which is there. So all of these guys are potential rational zeros. Doesn't mean that all of these guys are going to be zeros. that means that these are potential rational zeros. Okay, remember that when we're talking about zeros, you can have complex numbers, okay, or imaginary numbers. These are not included in here. You can also have irrational numbers like square root of 2. This one's not included. But if we can find at least one rational zero, then we can, if I know that there's at least one of them, I can then use synthetic division to try to figure out the rest of them. Okay, so this will be the answer right here. So I'm going to do another problem. Same thing, f of x is equal to 2x cubed plus x squared minus 4x plus 1, and we want to find the rational zeros. Okay, so this one will be a little easier. So we want to start off with p. P in this case is going to relate to 1. That's easy, it's just going to be plus or minus 1. The next one is going to be q. Q is going to be 2. So the factors are going to be plus or minus 1 and plus or minus 2. Okay. Now this can be really crazy, especially if you have huge numbers here. You're going to have a whole bunch of rational zeros. And at that point, you might want to use a computer. So P over Q is going to be plus or minus 1, plus or minus 1, and plus or minus 2. Okay. So I'm going to take out all of them. So it's going to be plus or minus 1 and plus or minus 1/2. So basically what it's saying is that the potential zeros could be this. So it can be x equals 1, negative 1, 1/2, or negative 1/2. Okay. So how do I know which one is it? Well, one thing that you can do is you can use synthetic division on all of them with this function, okay, and try to figure out if the remainder is 0. So one thing that you can do is you can start off by synthetic division, okay. So you can start off with the polynomial, so it's going to be 2, 1, negative 4, 1. And let's choose one. Let's say I wanted to choose negative 1. Okay. I bring that the 2, multiply, you get negative 2. Then you get negative 1. That gives me a positive 1. This gives me a negative 3. Clearly, this is not going to give me a 0. So this guy is not a 0. Okay. Another way that you can do it is you can plug it back into the original and see if you get a 0. So what you can do is you can keep going here and you can see how tedious this is going to be, especially if you have a whole bunch of different rational zeros. So let's choose 1 in this case. You could have chosen 1/2 as well. Okay, so let's choose 1. So I'm going to go down, put in the 2. So you got a 2. This is going to give me 3. That's going to give me a 3. It's going to give me a negative 1, negative 1, 0. Yes, that is the answer. So this guy, x equals 1, is a 0. Okay, so that means that, remember, we can write this function 2x cubed plus x squared minus 4x plus 1. We can write this as a factor of x equals 1 is a factor, so it's going to be x minus 1, and then the resulting, which is going to be 2x squared plus 3x minus 1. And then what we can do is we can try to factor this guy, okay, to figure out the rest of the zeros, okay? And if you can't factor this guy, well, guess what? Then you're going to have to do the rational zero test for this guy, find the rational zeros, and then do it over and over and over again. So you can see that the higher that this power is, okay, the more tedious this thing is going to be. So if you are having trouble trying to factor this, one thing that you can do is you can use the quadratic formula, because it's a square. So you can always just use the quadratic formula to try to figure out all of the rest of the zeros. Okay. So so you can do that on your own if you want to. Now for an exam, I'm not going to make you go through every single thing. What I will probably ask you to do is find the rational zeros, all the potentials. Then I'll give you a 0, and then you're going to have to find all the roots or give me the complete factorization. Okay. There might be also a problem where you have to explain if you had something really big, like 2x to the 10th power minus 4x squared plus 7, something like that, how will you go about finding all of the zeros for this big polynomial without actually doing it? So just remember to do the rational zero test and then multiple synthetic divisions, okay, until you finally have something that you can factor. So there's also something else that we're not going to talk about in this class. It's called Descartes' rules of signs. That's just another way that you can do it. I'm not going to talk about that, but just know that it exists. But yeah, so whenever you don't know the zeros, you don't know information about it, you have to do rational zeros and try to figure out all of them recursively. Just do them until you finally find 1 0.